Hey guys, so there was a request to see another type of problem, and a similar problem to the one that was requested is number 21 in the book, x cubed plus 4 over 9x cubed minus 4x. Remember, I want to do the partial fraction decomposition, what this started as before it was a single fraction, or if you want to write it as separate fractions. Now, in the book, if you read or looked at one of my examples, we have to have a proper fraction to start breaking it up. Otherwise, we have to use long division. If the degree in the numerator matches the degree in the denominator, then it is not a proper fraction. So we do have to do long division in this case. Okay, so that's the key for this problem, is you want to start by doing just that, right? So I'm going to do 9x cubed minus 4x into x cubed plus 0x squared plus 0x plus 4. Remember, you need these zeros as placeholders, okay? So I'm going to do my normal long division, okay? And I notice first that I need 1/9, right? 1/9 times 9x cubed is x cubed. So I'm doing the long division right now, okay? And then I have 1/9 times negative 4x is negative 4 over 9x, so I need plus 4 over 9x. Okay. X cubes cancel, and I end up with a 4 over 9x plus 4. Now the degree is less, so this is my remainder, if you recall. So this is going to be plus 4 over 9x plus 4, okay, and that's going to be over 9x cubed minus 4x. Okay, so I have this right here. Okay, so I know in my partial fraction decomposition I'll have 1/9, but then I got to break this up. Okay, so if I do that, let's just take this part. So I know I have this. I'll look at that using this later. I'm going to go through over here and say, okay, well, 4 over 9x plus 4 over, now 9x cubed minus 4x, I know I can write that, if I fully factor, as x times 3x plus 2 times 3x minus 2. That's fully factored out. Okay, remember, we always want to do that. And I'm going to set up my partial fraction decomposition like so. This part actually isn't too bad. All I need is a, b, and c over each linear factor in this case. There's no repeated factors, anything like that. Plus c over 3x minus 2. And then I'm going to go ahead, solve it out, set coefficients equal to each other, okay? So I know now that I have 4 over 9x plus 4 is equal to a times 3x plus 2 times 3x minus 2 plus bx times 3x minus 2 plus cx times 3x plus 2. So I'm right here right now. Okay, so this should look similar to the other problems. And I'm just going to go through and work on cranking this out. Okay, so this is going to be a times, this is 9x squared, okay, minus 4, that's a difference of squares right there, plus 3bx squared minus 2bx plus 3cx squared plus 2cx. Continuing on, 4 over 9x plus 4 is equal to 9ax squared minus 4a plus 3bx squared minus 2bx plus 3cx squared plus 2cx. I have a pretty large number of terms right here. Okay, and that's fine. That's no big deal. I just have to equate the coefficients. That'll generally make things a little bit easier, okay? So what I'm going to do here is I'm going to group things up. So I'm going to write on this side, I'm going to write 0x squared plus 4 over 9x plus 4, okay? So what I'm saying is the x squareds on this side should be equal to 0. The x's on this side should be equal to 4 over 9. And just the regular numbers, just negative 4a is equal to 4. That's what we mean by equating coefficients. So I'm going to group it up just like that. Okay, so if I look at it and I start grouping things up, I can write my x squareds like this. Notice I just took all my x squared terms and I factored the x squared out, okay? So I know that this right here has to equal to 0. Plus 2c minus 2bx. And with that, I did the same thing. That tells me that 2c minus 2b has to equal 4 over 9. And finally, all I have left here is minus 4a. That tells me that negative 4a has to equal 4. Okay? So let's go ahead and do this. So I'm going to do my first equation just for the plain old numbers. Okay? So for the plain old numbers, this tells me that 4 equals negative 4a. And it's easy to see from there that a is equal to negative 1. Okay? So I'll box that, right? So I know I'll have negative 1 over x in the end. But I still have to figure out what b and c are, okay? So if I use my, I guess we'll say x's, okay? Let's see what we got here. My x's would tell me that 2c minus 2b is equal to 4 over 9, okay? I need a little more information before I tackle that. And then I have my x squareds. My x squareds equation tells me that 0 equals, now I'm just going to fill in, since I have 9a, that's just going to be negative 9, plus 3b plus 3c. Okay? So now I have a, I have a b and a c, and I have a b and a c. Well, this is a 2 by 2 system right here. Okay? So I'll write this as negative 2b plus 2c equals 4 over 9. And I'll write this as 3b plus 3c is equal to 9. That's just getting everything lined up. Now, when you go through this, it's a little messy. You can go through, you can use your calculator, however you want to do it. Basically, the route I took is I did this. I said, okay, well, I'll multiply this one right here by 3, and I'll multiply this one by 2 with the idea of canceling the b's. So you go through, you do that, and this would give you 6b. Yes. So this would give you negative 6b plus 6c is equal to 4/3, and 6b plus 6c equals 18. Your b's would cancel, and you got 12c is equal to 58 over 3 when you get common denominators. Once you go through and you divide both sides by 12, you should end up with c is equal to 29 over 18. So I have c now, which is great. Okay. Finally, I got to go ahead and I got to find b. Okay, so I guess we'll swing over here real quick. Okay, so if I want to find b, what I can do is I can use this equation right here. 3b plus 3c is equal to 9. Okay, so 3b plus 3c equals 9. Now 3 times c, that's going to be 87 over 18. Plus 3b is equal to 9. If I subtract 87 over 18 off and I get my common denominators and all that fun stuff, I should end up getting, where did I put that number? Well, long story short, I should end up getting a 3b is equal to 75 over 18. Okay, because I think this is like 162 over 18. Divide both sides by 3 or multiply by 1/3 if you want to think of it that way. And you should end up getting 75 over 54, which reduces to 25 over 18. So a little bit messy with the fractions for this one. I think that's what makes it tough. So now when I put it all together for my partial fraction decomposition, remember, way back at the beginning, I had 1/9. Okay. Then I have to have a over x. That's negative 1 over x. So this will be minus 1 over x or plus negative 1 over x. Then I have plus b over 3x plus 2. That's plus, now I could say 25 over 18, but it might be easier to put the 18 down low. Times 3x plus 2, just like that. And then finally, I have c over 3x minus 2. I have c right here. This is plus 29 over the 18 times 3x minus 2. So that was a good one. Someone had requested one similar to that, because that one gets a little messy with the fractions. And the key to this problem, I think, is making sure that you know, oh, when they have the same degree on top of them, it's still not a proper fraction. We still got to do the long division. Okay? So hopefully that'll help you guys out.